Hello everyone. Today we are going to perform training for Labview on topics related to acquiring data for vibration analysis and other types of NVH analysis. And in this, we will basically show you how Labview code is built and how it is used to acquire data from sensors such as microphone or accelerometer. And in each of the slides, we will be presenting how to build the code from the basics and do also some understanding of the whole phenomena of lab for the lab view. So let's move ahead. Just go to the next slide. So that's the agenda. So what is LabVIEW? It's a unique programming software which is a bit different from the traditional ones. See, the whole idea of LabVIEW is that you will get to interact with the hardware, get the data from the hardware, convert it to the software domain, and then you can view the whole output in that. So that's the idea of LabVIEW. And the beauty of this is that you can also see everything in a pictorial format. So, all the block diagrams, everything, it can be seen in the pictorial format. And this is the uniqueness of this program. It's very easy to learn and understand from what I have seen. It the most important thing is that this is flexible. Okay, so you can basically customize the lab view to make your own code accordingly. There are many things that are needed first of all in order to look at LabVIEW software. What you need to do is you have to do the installation of the LabVIEW software. Then you also need a NI DAC MX hardware driver to go along with that. And so this you can either obtain through NI9234. Okay, so this is a 4 channel device, and this device is available on the NI National Instruments website, and you can get this device for the listed price. This will be used in order to collect data from the accelerometer or microphone or other sensors that are used in the noise and vibrations domain. Once this data is collected through the NI DAC MX, then the role of the LabVIEW software begins. You can get the data through various formats. Today we are going to look at the TDMS format, which is kind of patented format of LabVIEW, uh, and how that format can be used further to process that data. So all those things in particular. So what is LabVIEW? Basically, it provides the platform which can be used to interact with NI hardware. So like we just discussed, the NI hardware is say let's say 9234. Okay. Now that hardware is something which is, so let's look at this. Suppose you want to test a system. Okay, this is a cantilever beam, and you want to see what kind of vibrations are induced on this beam. So what you will do is you will install a accelerometer over here. Okay, this is the accelerometer, and this is connected to your NI9234. So this is your NI9234 system. Okay, it's a small box basically with 4 channels onto this. So you will be connecting the accelerometer through BNC connector to the NI9234. Okay. Now this NI9234 is then connected via USB to your laptop or to your PC. that you are using. Okay, so let's see. This is, suppose this is your laptop, and you will be connecting the NI9234 to your laptop, and over here you will be opening up your LabVIEW program basically. So all the data that you have collected for this cantilever beam, that you can see over here via various block diagram and functions that are available in the lab. So basically what you're doing is you are converting a physical phenomena. So this is a physical phenomena of vibrations, noise and vibrations. Okay. So this is physical phenomena. You are converting and looking at that and understanding how this system is behaving. So this is a very simplistic example, but you can pretty much do this to any type of application. So that's how LabVIEW. That's where the LabVIEW is, really helpful. So it interacts between hardware and software, and also provides you with legible output, which can be then, used to understand how the whole process works. Again, it acts like a platform to read the acquired data and process it. Okay, so the whole data that is acquired, this data is basically first of all converted from the physical domain to the electrical signal via the accelerometer. Okay, now this is again then converted to your digital format via this NI9234 device. So it has got a built-in signal processor also, and once this data is processed, then you can look at this data on your computer via this LabVIEW software. So that's a platform that will help you to read the acquired data, and then you can further process it. So the processing part also we will look at in this presentation in quite detail, and the whole process will be explained in this. The processing of the data can be done either online or offline. So this is a very important concept, online or offline. So by this, what I mean is online is a real-time data processing. Okay. So let's look at this now. When the data is getting acquired through your physical system and accelerometer or sensor and NI9234, okay, you can either process that while the data is getting acquired, that is in real time, or you can process it or analyze it later on via different modules that are available in the LabVIEW, and let's say that will be an offline kind of data processing. Okay, so sometimes in some applications you definitely need to go back and look at the data and process it offline and then create a different kind of module. Okay, or sometimes you definitely need to process the data real time. So suppose you are testing the bearing for a long duration of time, then real-time data processing can be very helpful, because then you can set limits for the amount of vibrations that are induced at certain frequencies, and then if it goes beyond that, definitely the real-time data processing will be very helpful, because then you can identify the defective bearing accordingly. Or offline data is something which you can collect the statistics of the data, like how many bearings have been defective now. Okay, so all that information can be collected offline as well. So the beauty of this is that LabVIEW, you can either use it online or offline, or online and offline as well. So that's where LabVIEW is so very powerful. Variety of data acquisition and processing applications can be developed in LabVIEW. So the LabVIEW that we are using is for mostly for NVH, that is noise vibrations area. However, acoustics, sound, acoustics, different areas you can also use LabVIEW. Not only this, but also in the fluids, thermal, uh, various different areas LabVIEW and data processing can be used. So here's a program in Python that was devised by my associate Shivani. Basically, we just wanted to show you how the Python script is matching up with LabVIEW and how you can collect the data via Python as well as in LabVIEW and how it is comparatively achieved. We'll not go in detail of this. Maybe in next video we can get Python also Shivani included in this, so that our subscribers will be very happy with this. Okay, so here's how the LabVIEW will, start up. Will look like this. Basically, all your recent files you can see over here. Okay, so we have worked quite a bit on different kind of projects, and you can start with a blank VI. I think this is where you will have to begin. Once you start that, you have to understand that there are two parts in LabVIEW. Okay, in this application, there are two parts. Mainly, first part is the front panel. This is the front panel, and then there is a block diagram. Okay, the block diagram is like the brain of your LabVIEW. Okay, and the front panel is your screen. So this is what you will see outside, and then that way the whole application is actually divided. The front panel will host the user interface. Okay, it will have all the controls and indicators. So as a user, when you run the LabVIEW file, or when you execute the LabVIEW file, you will see there are different controls like scroll bars and other things that are normally available, or you can input some information in the text boxes and then press enter or OK and something like that. Or there will be indicators also like red lights or a green light and other things that will appear on the screen. So this is the front panel will host all these things. The block diagram is, like I said, the brain of your LabVIEW application. So the block diagram will host the whole program or the code. Okay, and for each program or for each code behind the scenes, all these things will happen, and that will be in the block diagram. Okay, so as a as a LabVIEW developer for the NVH area, in the NVH area you will have to basically look at how to create a block diagram. Okay, and I'll tell you this from my personal experience. For the last say 15-20 years, I've been using the LabVIEW block diagram, and it is really very helpful. There are so many already built-in subroutines available in this, and for each of the subroutines, a lot of plethora of information is already available on the NI website or in the NI help menu, LabVIEW help menu. So already a lot of subroutines have been developed, so you don't have to reinvent the wheel all the time. Okay, so we'll look at a few today, and then as we go along, we plan to make more videos like this, so that will help you to understand LabVIEW and basically the idea of using LabVIEW in the NVH area. Okay, so the front panel will help the user to provide input and see the output of the code. So yeah, I mean, just like we discussed previously, the front panel, which will, which you will see on the screen, that will help you to provide the input so you can interact with the LabVIEW code, and you will see the output, the plots, the graphs, or the other information that you get through this LabVIEW. So that's how it will work. Right. So here's a slide which is a excellent slide. This will show us as to how the front and the block diagram will look like. Okay. On the right hand side, you can see this is the front panel. Right. So this is the front panel. This is actually while you're coding or while you're developing the LabVIEW code, you will see something like this. Okay, and you can add user interface here, and this is the code of the block diagram, so you can add code here. Okay, and the beauty of this LabVIEW is that if you add something onto your block diagram, so let's say suppose if I add a DAC MX TDMS file reader. Okay, if I add something here, you will see similar to this, you will see on the front panel as well, as to how the TDMS file can be read. So, or something like this. It's very interactive actually. And once we look at the application, you will get to know more in detail of this. So this, the whole front panel plus the block diagram, this is called the VI, okay? And the LabView VIs are already, available. Lot of VIs are already available, which you can simply use example VIs. You can modify those. And frankly speaking, we have used quite a few of the example VIs to modify in our company, and they are very very helpful. The VI stands for virtual instrument. Okay, it has got the front panel and the block diagram. The windows can be switched between using the control plus E command. Okay. This is a shortcut given to you. You can use this very well. So here's a simple example, very good example, Shivani. And what we have here is basically a block diagram. So we are just simply multiplying two numbers here. Okay, you can put in these controls, something like similar to this. Okay, this is DBL, and then you can put an indicator which will show you the output. You can start and stop the button here. Okay, so this is what you look like, it will look like in the block diagram. Okay, and whereas in the front panel, if you see, you will see something like this. So the numeric control, you can change it using using these buttons. Okay, so suppose I have four, I've chosen 4 and 5, then 4 5s are 20. So that's what you will see as an output over here. You can stop any time you want. Okay, you can change the number accordingly, whichever numbers you want. And so a very helpful simple program. That's how it will be. It can be programmed in LabVIEW. Okay. This is a simple numeric example. There are many other applications that we can go through in this. So the front panel, how it will look like? The front panel will host the controls, that is input from the in the form of file paths, arrays of values, switch on and off. Okay. The indicators are typically graphs, tables, single values, booleans, etc. The output can also be in the form of report, that is Excel or Word. So this is also very very important attribute of the LabVIEW, that you can actually save your data in the form of an Excel sheet. Okay, or you can save it as a Word file. You can publish this as a Word file, or you can save it as a Excel sheet. So this is very very important attribute. Not everything, not something like this is available in other software that I have seen previously. So, all the graphs, tables, everything you can save in whatever format you want, and you can simply code. So we'll be doing a code app, it's something similar to this, where you can, save all the files. And so let's look at most few examples. The block diagram, the significance of the block diagram is that it has got all the code which is used to execute. So like I said, this is the brain of your computer, of your LabVIEW, and LabVIEW is basically a, like I said,